Good afternoon, class. So today we're looking at equations and inequalities. We're looking at the examples. Equations with, nope, not that one. Equations with more than one term in the denominator. Okay. So this is example 1 on page 75, and this is the examples for exercise 4.3. Okay. So we start off, we always try and factorize the denominator if possible. Okay. If we look at this denominator here, does it need to be factorized? No, the denominators in this case is already factorized. Okay. So at this point then I can, after factorizing, we can then find the LCM. Okay, and what's my LCM here? LCM is x plus 2, x minus 4. Now if you look at the second fraction, in that denominator you got that x minus 4 is already accounted for, not so, x minus 4 is already accounted for. Thank you. However, I'm shorting the 2 there for that denominator, not so. So your question you're asking yourselves, what must this fraction be multiplied? What must that denominator be multiplied to get the LCM out? It's shorting the 2. Not so? Yes. Alright, so let's go there. You must multiply this by 2, of course. Multiply it by 2. And then, so in other words, we got 2 into 2x minus 5 over 2 into x plus 2, x minus 4. You all agree with that? Yes. And this is equal to, what is that fraction's denominator shorting? X plus 2. Can you see that? So it's 1 into x plus 2 over 2 into x plus 2, x minus 4. You all understand that? Yes. Right. Now, if you have, say, x over 3 is equal to y over 3. What can I conclude there? X over 3 is equal to y over 3. What can we say there? X is equal to 1. Why? Because the denominators are the same. So for those equations to be equal, the numerators has to be the same. Not so. So therefore x is equal to 1. Okay. So therefore x is equal to 1. So what you notice here is that these denominators are also the same. Can you see that? So what can we conclude from them? We can conclude that 2 into 2x minus 5 has to be equal to 1 into x plus 2. You all understand that? So from now onwards, I'm not going to do this step here. I'm going to go from there straight into that step. You all okay with that? Yes. Right. So let's go. We're simplifying, we're getting rid of the brackets in pursuit of solving for x. Is there something else here that I had to say as well? The restriction. Now the restriction is the values for which x can never be equal. Okay, why? Because if x is equal to, for argument's sake, if this denominator comes to be an answer of 0, then that means to say the sum will be undefined. Or if there's a 0 here, the sum will also be undefined. Not so. So that is coming from the LCM. We know that x can never be equal to, not 2. X can be 2. It can't be negative 2. Why? Because a negative 2 plus 2 is 0. Can you see that, people? So it can't be negative 2, as well as x can never be equal to, for this one here? 4. So those are the things we're going to write when we do the LCM as well. We say the restriction or the values for which x can never be equal to. Okay, yes? No, there's no mark. However, if you see by writing this restriction here, this reminds us the values for which x can't be equal to. So that's basically like a guide. Okay. So let's carry on. So let's solve for x here. What do we get? Multiply this in. You're going to get 4x Minus 10 is equal to x. So what do we do now? X is one side, number is on the side. We take x on that side and a number on the side. So you got 4x minus x equal to 2 plus 10. Not so? What's 4x minus x?
3
Is equal to?
12.
Divided by 3 both sides. So x is equal to?
4.
But you say, hang on. What do we notice here? X can't be 4. There we go. So there is no, therefore, no solution. So what does that mean? That means to say I can choose any value for x. It will never work out. The equation will never balance. Okay, you understand, people? Any confusion? No? Right. Now there's a lot of new kids here. If you don't understand or you're too shy to say, come speak to me. I can give you last year's grade 9's lesson on this. Okay? You can build your basics to it. Cool. Okay? Because this work doesn't start here. Okay? It starts in grade 9 already. Remember, we did a lot of fractions in grade 9 and grade 8. It wasn't in vain. Okay? It wasn't unnecessary. This is the reason why. Okay? Right. People, this is example 2 on page 75. Okay. Right, example 2 on page 75, we are told solve for x. Right. What is the first thing we need to do? Factorize the denominator. So you didn't know that? Write it down. We're going to factorize the denominator. Right, so let's look here. So that's a trinomial, so that can be factorized. This I'll swap around, and that I'll swap around. Why? Because I want it in the form of ax plus b. I want it in that form. So that it's easy to pick out my my common factors, or my LCM. Okay, so let's go. So that is your trinomial then. So it's going to be 3x minus 2 over. The trinomial here is going to be x minus 3, x plus 2. And this is equal to, if I swap that around, is anything going to happen on that fraction? Why? It's a plus, not so. So this is recording. Alright. So it's going to become x over x plus 2. If I swap this around, what's going to happen? Negative is going to come out. So that negative that comes out, the times this positive will be negative over x minus 3. Okay. You all understand? People, what's my LCM here now? X minus 2, x plus 2. Okay. LCM, x minus 3, x plus 2. Which is this denominator here. Not so? But is the x plus 2 accounted for? Yes. Is the x minus 3 accounted for? Yes. So that's my LCM. What's my restriction? The values for which x can never be equal to. So that one is going to be x can never be equal to 3, or x can never be equal to. Okay, and that's the values for which x can never be equal to, otherwise the sum will be undefined. Okay, so what must this denominator be multiplied by? 1. What must this denominator be multiplied by? This here? Okay, can you see that, people? Why do I multiply the numerator as well? Why? To get equivalent fractions. That's the reason why. Okay, so it's going to be 1 into 3x minus 2 equals x into x minus 3 minus x into x plus 2. What do you also notice here? That I'm not multiplying it out immediately.
Yes.
Okay? We don't want to make a mistake there. Okay, because if you're going to multiply out wrongly with the sign there, or mess up a sign, then you won't be able to factorize the trinomial most of the time. Okay, so let's go. We get rid of the brackets here. Alright, so what we get now? 1 times 3x is?
3x.
3x minus 2 equals x squared minus 3x minus x squared is minus 2x. So as you can see, it's a quadratic equation. Wait, first we add like this. We guys didn't do quadratic equations. Okay, so that cancels. So what we do? X is one side, numbers are the other side. So we're going to keep 3x here, plus 3x, plus 2x is equal to, and not negative 2, positive 2. Why? Because I'm bringing the x's to the left, and the numbers to the right. Can you see that, people?
Yes.
What's 3x plus 3x
6x.
plus 2x?
8x.
8x is equal to 2. How do I get x on its own?
Divided
By 8 both sides. So therefore, x is equal to 2 goes into 2 once, 2 goes into 8, 4 times. So the answer is 1 over. Is that correct? Any confusion there? Look at example 3. Example 3 is on page 76. So example 3 on page 76, we are given, solve for x again, or solve the equation. Does the denominator need to be factorized here? No. Okay. So what needs to be done? Swap that denominator around, swap that denominator. Not so? Only the one. Okay, you're right. Is it going to change the sign here? Yes. It's 4 over x minus 1 minus 3 over x minus 1 is equal to 2x over x minus 1. You see that? What's my LCM? X minus 1. As you can see, it's accounting for all of those denominators. What's my restriction? X can never be equal to 1. Why? Sum will be. So what must this line be multiplied by? 1. This here? That fraction, sorry, no? This here? So in other words, I'm going to get 1 times 4 minus 3 times 1 equals 2x times 1. So that's going to give you 4 minus 3 is equal to 2x. 2x is equal to 1. X is equal to? Sorry? What do you say? Negative 1. Okay. You see that? You're saying, okay, so you say that's going that way, so it must be negative 2x equals. This was 1 here, not so. Becomes negative 1. So you divide both sides by negative 2. So x is 1. So what happens is you swap the whole fraction, the whole equal sign around, everything on the left becomes on the right, and everything on the right becomes on the left. Is exactly the same. Okay, so you don't have to change in that case. Okay. Anything else, people? No. Alright, so that basically brings us to the end of the examples for exercise 4.1. Nice.